If you sample every one of them, you should be able to find out the expected value of x. That means you pick every one and then divide by n. So there surely must be a mean of x. Mean of x means every single one. 1, 2, 3, 4, 5, everybody divide by n. Let it be mu. The population surely should also have a variance. Correct? All populations should have a variance. This is the variance of x, where x is the height. Say, for example, height of a randomly chosen person. No problem. We all know about that. And we also learned that what if x is a normal distribution, you can calculate what is the probability x smaller than 1.65, 1.62, greater than 1.8, whatever. No problem. What we learned on Tuesday is this. Now, if I randomly select, say, 3 of them, that consists of, maybe not 3, don't always use 3, use 5. Okay? Randomly select 5, that consists 1 data point. Another 5, another data point, another 5, another data point. This is called x bar, which is x1 plus x2 plus x3 plus x4 plus x5 over 5. Now, x bar is also not a constant. X bar is also a distribution, because anytime you pick 5, randomly pick 5, divide by 5, every time you pick a different 5, you get a different value. It's also a distribution. Now, what we have learned on Tuesday is this. We have learned, we learned the expected value of x bar, of course, not surprisingly, is the same as expected value of x, which is mu. This one, okay, quite easy, correct? I randomly pick 5 divided by 5, the expected long-term average value should be the same, correct? We also learned on Tuesday that what is the variance of x bar. Now, this is slightly different. We learned that this is actually sigma square over, in this case, 5, which is sigma square over n, depending on whether you pick 5 or pick 6 or pick 7. Follow what I'm saying? In this case. So far, so good. Yes? So far, so good. Now, another one distribution that I really didn't explain, but it was in the notes, was this. Let's say what happens if you have t, which is actually the sample sum. Now, this is just an extension of x bar, correct? What is the expected value of t? Which is actually not difficult. That means you pick n. What is the long-term average value of that sum of the n? It should be n times mu, correct? N times mu. Agree? All okay? Yes? Make sense? N times mu. And then what is the variance of t? Is also n times sigma square. Do I need to prove this? I don't think it's needed, because you just make use of the fact that x1, x2, x3 are individual or independent observations of x. Correct? Independent observations of x. You actually just make use of the fact that you use this idea, right? Variance of ax plus by equals to a square variance x plus b square variance y. Now, as long as x and y are independent, then you can do this. Now, x1, x2, x3 are independent, therefore you can just variance of x1 plus variance of x2 plus variance of x3, etc., therefore you get variance, n times variance. So far, so good. That's what we learned. Now, throughout Tuesday, what we said also is that we learned this in general. I don't care what is the distribution of x. Now, Tuesday, we also say, okay, if x is a normal distribution, then it makes perfect sense that x bar will be a normal distribution, will follow a normal distribution. T will also follow a normal distribution. Clear cut. Normal plus normal give us normal. So we had example 1, example 2. Follow? All good? Okay, let's carry on. There you go. So far. Okay, example 1, example 2. Now, interesting thing about example 2 is this. Okay, let's shrink it a little bit just to get an overview of example 2. It's a bit small, but never mind. You have it on your notes as well. What we said was this. Now, part 1, you had 2 rods are selected. What's the probability that the total sum is less than 0.994? Then you get this kind of probability. The difference between part 1 and part 2 is that part 2 talk about a diameter of 1 randomly chosen rod. So there's a difference. Part 1, we talk about R1 plus R2 because clearly we pick 2 rods. Part 2 is not R1 plus R2 anymore because you only pick 1 rod. So D is actually 2R. So distinguish between these two. What is the difference between R1 plus R2 and 2R? Because clearly they have different distribution. As seen from the final answer, probability, same number, 994, 0.994, 0.994. Clearly, these two values are different. Correct? They are different because R1 plus R2 and 2R are two different distributions. Follow what I'm saying? So I'm going to now just, without doubt, clarify this part. What is the difference between x1 plus x2 and 2x? It should be quite clear by now. If x is the weight of a melon, the weight of 2 randomly chosen melon must be x1 plus x2. Very good. Now, if I pick 1 melon and I multiply the weight by 2, then it must be 2x. Correct? Now, you can go on to write down what is the variance, what is the difference between these two. I'm not going to go through. You can go on and answer this question by yourself. Then what is the variance of x1 plus x2? What is the variance of 2x? Are they the same? You can go on to write down. I'm not going to go through. You should be able to tell me. Because the answer is in example 2. Follow? Yeah? The answer is in example 2. Okay. Cool. Let's move on. Example 3. Okay, we can go faster now because you clearly know the technique. Actually, I can stop the lecture now. Quite easy already. All I want to say is say, actually it's just example after example after example after example after example. Okay? Can? We'll move faster. Okay. Tell story only lah, stats. All very wordy. Just have to pick out the important things. Okay? Your mind must have a highlighter. Only read the important things and don't be distracted by other things. Look, spinach have weight that are normally distributed, mean 150, standard deviation 10. In my mind, I will only pick up all these things. I will say S follow a normal distribution, 150, standard deviation 10 squared. In my mind, you can write this in your head or you can write it down. Actually, it's all in the notes. Okay? Then you have kangkong. Actually, it's in the notes. I actually don't have to copy. I'm just practicing for you how you should read the question. Alright? Then you say, oh, kangkong, green color. There's this spinach not green color, but never mind. 180 and 15. Okay, so I'll say, oh, kangkong. Kangkong is K. K follow a normal distribution. 180, 15 square. Whatever lah. Now, then that's why this thing become important, right? Your definition. I always say to my classes, this definition of random variable, trivial as it sounds, is critical to your working. Not just because it gives you marks. I don't think it really gives you marks. Even if you write this one down, I don't get answer, you won't get any marks, I tell you. But really, if you define your random variable properly, the rest should be simple. It will really help you. So we say spinach S be the weight of a bundle, a bundle of spinach, and K be the weight of a bundle of kangkong. So one only, one randomly chosen spinach and one randomly chosen bundle of kangkong. What does the question want? The question wants the probability. The question wants the probability that the average weight of 5 bundles is less than 160. 5 bundles comprises of what? 5 bundles, not 5 spinach, 3 spinach and 3 bundles of spinach and 2 bundles of kangkong. So now, let V now be the average weight of 5 bundles. Now, can we? Yeah, I don't want to V lah. Anyway, the answer is in the next line. V is the average weight of 5, which means you have S1 plus S2 plus S3, because you actually pick 3 bundles of spinaches, not 3S, but S1 plus S2 plus S3. N plus K1 plus K2 divide by 5. Now be very careful, okay? Like that will clearly give you the average of 5. Don't say but it's not S bar plus K bar over 2 wrong correct or not? Clearly wrong or it's different it's just the average of 5, it must be divided by 5. Follow? Okay, so with this, then we can carry on. Actually, this part, even if you have not attended lecture on Tuesday, this part you can clearly do. It's just normal distribution because S1, S2, S3, K1, K2 are 5 independent observations. Just treat it as A, B, C, D, E. Correct? So what is the expected value of V? You factorize the 1/5 out. You get expected value of S1 plus expected value of S2 plus expected value of S3 plus expected value of K1 plus expected value of K2, like that. Make sense? Could we factorize the 1/5 out? I think we can. Now, I think the answer is out. Right? S1, S2, S3 are 3 independent observations of S. Correct? So these 3, expected value of S1, and this one are all the same, which is expected value of S. Plus 2 expected value. Okay. Now I'm a bit, of course I write a bit more in lectures. Or I write a little bit more in lectures so that we can all see how we arrive at the answer. It's important. Alright, it's important. Then finally we put the numbers in. 3 times 150 plus 2 times 180. Then we get 162. Of course, this is the final answer that we're interested in. Now, what about variance? Variance, be very careful, alright? Be very, very careful. It's very tempting to cut, to jump step and then you will get variance, but let's do it carefully. Again, we say we treat S1, S2, S3 as K1, K2 are 5 separate independent observations. You can easily say, you can factorize the 1/5 out. Not factorize actually. It's actually like that, right? Sorry. Make sense? Be very careful, excuse me. This is 1/5 square. We are actually making use of this idea. Variance of AX equals to A square variance X. Simple as that. Just like that. Nothing fantastic. We're just making use of this here. Okay, just treat This whole thing, S1, S2, S3, S4, S5, S1, S2, S3, K1, K2, this whole thing as X. Correct? And that's why you get the A squared. That's how we get the 1 A squared. Follow, Kumar? Make sense? Yes? So, I think the answer is quite obvious now because this one are all the same. These two are all the same. Correct? There you get that. Our final objective really is to know what is the variance of V, expected value of E, V, and variance of V. Once you know these two numbers, it's quite okay, done. Once you know these two numbers, because S1, S2, S3 are normal, S follows a normal distribution, K follows a normal distribution, V must follow a normal distribution, just press calculator, answer is out. Any questions? Manageable? All right? Make sense? Am I going too fast? No, good. Okay. Next part. Next part, what did they ask for? Next part, they asked for the average weight. Find the probability that the average weight of the 3 is less than the average weight of the 2 kangkong by less than 20 R. Okay. This kind of phrasing, you must be very comfortable. It may sound very difficult at first, but you must practice forming your mathematical statement. This is just a word problem, but you must form your mathematical statement. What does it mean to have, average weight of 3 to be less than average weight of 2 by less than 20? Wow, quite a mouthful actually. Okay, without doing anything, okay, all look up. Practice. Of course, later we must define properly but suppose average weight of 3 is S bar. Suppose average weight of 2 kangkong is K bar. And you want this to be less than this. Correct? You want this to be less than this. So actually you want K, this minus this to be a positive number. Correct? So far so good. You want this to be bigger, ma? You want this to be less than this by less than 20 grams. So does it make sense to all of us that you want this to be more than this by less than 20? Make sense? Make sense? You want kangkong to be more than S by less than 20. So actually it's this. You want this to be less than 20. So we learn this mathematical statement formation. Then after that it's very simple. After it's just calculation. Make sense? So we move on again. So S bar is S1, S2, S3 over 3. By now we should be quite comfortable. What if S follow a normal distribution, S bar should follow a normal distribution with the same mean, which is 150. Okay, you fill in the variance, or rather variance, correct. Can you all fill in the variance? 30 seconds. Fill in the variance, check answer with your friend. Come on. Yes. Yeah. You want me to I'll address that. Okay, can. Understand. Okay. Now, clearly this is variance over 3 over n. This is variance of k over 2. Alright? Can? All got that? Now, k bar minus s bar must follow, therefore, a normal distribution. Now, k bar is a normal distribution, s bar is a normal distribution. Normal minus normal will clearly be normal. I don't think we need to elaborate more. This is 180 minus 150. What is the variance? Variance is the addition of the variance. Then you do the arithmetic, you will get it. Now, let's be very careful here. You want this to be less than this. So this must be a positive number. K bar minus S bar must be a positive number because you want it to be less than this. So strictly speaking, I think that there's something missing here. Strictly speaking, this one, sorry, I better do it in red. You want probability sorry, like that. You want like that, right? Just now I was a bit not incomplete, I was incomplete there. Huh? You actually want k bar minus s bar to be between 0 and 20. Because you want s bar to be less than k bar. Correct? Does it make sense to all of us? Does it make sense? Yeah. So, answer should be 0.197 3SM. Ken, any questions? All alright? Good? Thanks. Okay, last part. Last part. Yeah, let's move a bit faster. I think we can move faster. If spinach costs 30 cents per 100 grams and kangkong costs 35 cents per 100 grams, find the probability that the total cost of 5 bundles exceed 270. Now we're going to define properly. Let C be the total cost of 3 30 cents per 100 grams. So cost is 30 cents per 100 gram. S1 plus S2 plus S3. Now let's digest this bit first, okay? Because S is in grams, correct? Because S is in grams, it costs 30 cents per 100 grams. So you must divide this by 100 grams first, then times 30 cents. So this one will be so therefore it's in dollars. Follow? Make sense? Plus 0.35 divided by 100, K1 plus K2. Now once you can write this thing out, the rest is easy. The rest is really easy. Alright? But I purposely left this blank because it's for us to practice how to arrive at all these 2.61. Okay, imagine you don't see all these, okay? Imagine you only see 2.61. Are we able to very quickly get from here to 2.61. Let's practice. Let's practice. Expected value is very simple. Expected value is 0.3 over 100. Expected value of S1 plus expected value of S2 plus expected value of S3 plus 0.35 over 100. Expected value of K1 plus expected value of K2. Now, some of you may ask me, do I have to write so much in exam? I give you a quick answer, Ken, because in lecture I must give you all these so that you can really know how I arrive at that. I will tell my classes this: minimum, bare minimum you must write. You must be able to give me this. You must be able to give me this. Then final answer. There's no way you can jump from, you should not jump from, you should not jump from, what am I doing? Here to 2.61, cannot. The minimum you must give me is this one and equals to this working with numbers substituted in, answer, minimum. The reason why I write so many lines is for us to understand. Any questions? All right. All right. Similarly for variance. Variance must be, don't want to write, lazy, you all see, okay? Okay, remember the square? Variance of S1, variance of S2, variance of S3, and then this square. Remember the square. Then you get these answers. Please be reminded, this is your intermediate step. Round off to at least 5 SF. Now, some of you may lost some marks in your CT2 because of this. Your intermediate step, you don't want to round off. Then final answer, you don't get the exact answer. Or rather, won't get the 3 SF answer. Alright? If you ask me, I won't even, I think this is probably exact 5 SF, but if you ask me, the more SF I have, the better it is. I just put on, and I store it in my GC. I use that exact answer to calculate my intermediate step. You know how to store, right? Don't know. How many of you don't know how to store values in your GC? Don't know. Best. 1.5 years. Don't know how to store. Ayo, goodness. 45 times where's the square root 5. This one, not exact answer. Many SF. You want to copy, you can copy 100.623. You just store this one. You can store into which one? There's A, B, C. You see the green letters A, B, C, D, E, F, G, blah, 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 blah. Okay, 26 memory. Alpha A. Then A is this already. Next time you want to use A, you just use A. A minus 100. Ta-da! Oh. Nobody taught you Don't bluff lah. My tutor must have taught you, but you never listen Oh. I will do this You have 26. Choose. Okay, go and choose which alphabet, which letter you like. Okay, Ken, let's move on. The GC is done. GC work is easy. Okay. Example 4. Now let's stop this for a while.